Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate Now we're going to use our unit circle, the ordered pairs on it, to build the cosine function. Now this time when you look at your values on the unit circle, because we're doing the cosine values, you're using the x coordinates at each of these angles. And again, the angles you want to use here are just these ones here. It's all the 90-degree angles on our unit circle. Okay, let's begin. So go to 0 pi. 0 pi on the unit circle, the cosine, or the x-coordinate, is 1. Now go to pi over 2. The cosine at that angle is 0. Now go to pi. The cosine at that angle is -1. Next, go to 3 pi over 2. The cosine at that angle is 0. Finally, go back to 2 pi, so you've gone completely once around the circle, and look at the cosine of that angle, the x-coordinate. It is 1. We now have our data, so let's sketch it. So this, it looks like it's a V, but it's not, and let me show you. I'm going to continue the pattern on the left here. Now again, I told you last time with the sine, to do the negative angles, what you can do is just count in a clockwise fashion and go around your unit circle that way. Or you can just follow the patterns. Based on the pattern, at negative pi over 2, I know the point will be on the x-axis. At negative pi, it'll be down here. At 3 pi over 2, it'll be back up here. And at negative 2, it'll be up there. Now do you see the periodic behavior? So let's sketch it. So here is our cosine wave. So let's do some characteristics. The domain of the cosine wave is all real numbers. The range you will see is -1 to 1. The midline is the x-axis again. The amplitude is the distance from the max and min to the midline, and you can see it's 1. Now let's try to figure out the period. So in this case, I always like to start when the input is 0, so I'm starting up here. So if I follow down, if I stop, I can see I've only done that part of the values above the midline. So I'm going to keep going, gone down to my min. If I stop here, I've done all the values below the midline, but not all of the values above the midline, so I need to keep going. Now I'm going to stop here, because now I've done the other part of the values above the midline. See, between this piece and this piece, I will have all those outputs that are above the midline. And now I can look and see I've traveled 2 pi. My maximum is 1, my minimum is -1, and now this time my y-intercept is actually 0, 1. Compare your cosine function now. This is the parent cosine function here. Now, if you compare these characteristics to the sine function, they are almost identical. Be very careful though. Cosine is symmetric to the y-axis. It's an even function. The sine function is actually symmetric to the origin, and it has odd symmetry. Hopefully you remember even and odd symmetries from previous parts of our year together.